In this video, we will show you how to run AI on the Zynq 7020 board to recognize common objects. The purpose of this video is to demonstrate that even low-end FPGA chips, like the Zynq 7020, can run powerful AI algorithms for a wide range of applications. The boards that this demo is currently applied to are Digilent's RDZ720, PINK-Z1 board, and TUL's PINK-Z2 board. These boards use AMD's Zynq 7020 chip and provide HDMI video input-output interface. It may also be supported on other boards that use the same chip, so please request it in the comments. Here's a simple way to run it. First, download the installation file. Second, unzip it and save it to an SD card and insert it into the card. Third, connect the HDMI cable between the laptop and the secondary monitor. Fourth, connect the power. That's it. Easy, right? Specifically, download the AI on Zynq2.zip file, unzip it, save it to an SD card, and then insert the SD card into the board. Instead of connecting the HDMI output of your laptop directly to the monitor, connect it through the Zynq board. That's it. You're ready to go. The second screen of the laptop is displayed on the monitor with the AI recognition results overlaid. Let's place various objects on this screen and examine the results. When powered on, a model that classifies 190 objects runs. What you can see on the blank desktop is that the object closest to the current desktop image is an envelope. As you move your mouse pointer over it, you can see that the recognition probability changes slightly. Let's try adding a partial image of a cat to the desktop. When only a partial image of a cat is shown, it is recognized as a wolf, dog, fox, etc. But when the cat's defining characteristics appear, it is recognized as a cat. Let's try recognizing cat images by searching for them on the internet. First, Google cat, then choose a cat image, copy the URL, and run that URL in another tab of your browser. Let's try to recognize the fox in the same way. This is a very plain image of a fox, so let's try recognizing a more complex image. Next, let's try to recognize a wolf that looks similar to the dog, or the fox using the same method. In the same way, we recognize an image of an elephant. In this state, pressing the second button from the right among the 4 push buttons on the board switches to the ImageNet model that recognizes 1,000 objects. When the model switches, you can see that the result that was recognized as an elephant has changed to an African elephant. Now let's try to recognize another elephant image. This time, it recognizes it as an Indian elephant. Next, let's search for an image of a Siberian husky and try to recognize it. It recognized it as a Siberian husky. Next, we will search for and recognize an image of a Malamute that resembles a Siberian husky. Oops. 2 types of dogs, together. Let's choose another Malamute image. The Malamute image was recognized correctly. Next, let's recognize an image of a chow chow dog. The chow chow image is recognized as just chow. Next, let's search for an insect image and recognize it. It successfully recognizes a ladybug. Let's choose an image of another insect and try to recognize it. What is it? It recognized it as a damselfly. I googled it separately and found out that a damselfly is a type of dragonfly. This image is a close-up of the head of a damselfly. Next, let's recognize different types of ships. I found out that a boat of this shape is called a schooner. Let's choose a different ship. This is recognized as a container ship. As explained in the previous video, the recognition results can be received as electrical signals through connector pins on the board, or the results for all image frames can be received through the serial port. These results can be utilized to implement various application services. So far in this video, we have shown how to recognize various objects using the Zynq 7020 FPGA board. In the next video, I will show you how to compile Verilog hardware source code with Vivado software to create the contents of the AI on Zynq.zip file. Thank you for listening.